Bridging abstract theory and dynamic reality. The blueprint of rotational physics. The derivation sheet serves as the essential cognitive anchor for the entire study, providing the rigorous why behind every visual movement seen in the simulations. While the diagrams represent the flow of information and the progression of learning, the derivation sheet acts as the foundational truth that prevents these animations from being mere digital art, transforming them into precise physical models. The logical engine of the sequence diagram. In the context of the sequence diagram, the derivation sheet represents the theory participant that drives the entire interaction. The narrative begins with the sheet defining the basic characteristics of how a solid body rotates, establishing that the flow of such a system is constant and does not leak or compress. The significance of the sheet becomes most apparent when it provides the mathematical proof that certain forces are conservative. This theoretical handoff allows the simulation engine to create a visual test where objects traveling along completely different paths end up doing the exact same amount of work. Without the derivation sheet's proof of path independence, the sequence of events would lack the logical justification needed to move from simple motion to the complex energy frameworks that follow. The pedagogical pivot of the state diagram. Regarding the state diagram, the derivation sheet provides the critical examples that act as bridge points between the demos. It facilitates a purposeful transition from visualizing fields to understanding the effective potential, a concept where rotation is viewed as a landscape of hills and valleys. From local motion to energy landscapes. The sheet explains how an object sliding on a rod is actually falling down a hill of stored rotational energy. This insight is what allows the learner to transition from watching a spinning bead to understanding the conservation of energy in a rotating frame. From mechanical rods to cosmic orbits. The final and most significant contribution of the derivation sheet is scaling these local mechanical rules to a universal level. It identifies the centrifugal barrier, a steep wall of energy that prevents a planet from crashing into its sun. This theoretical pillar is what makes the final transition to orbital sloshing possible, revealing that a planet's complex path is actually a simple oscillation trapped within a stable valley of energy. Ultimately, the derivation sheet is the narrative's connective tissue, ensuring that the sequence of learning follows a logical path and that every state of the simulation is backed by a deeper physical reality.